This conference will now be recorded.
Yes, up to now you have learned linear and polynomial regressions in supervised learning. As you have seen in the introduction, and this is Prabhu Kumari, and I am going to teach the classification algorithms today. And you already know that under supervised learning there are nothing but two types of learnings called regression and classification. Okay, we have done with the regression algorithms. Today let us continue with the classification algorithms. What do you mean by classification? First let us see what is the classification. Classification is nothing but it is the process of categorizing the given set of data into the classes. Okay, let us justify this statement called process of categorizing the given set of data into classes. See, you have seen some, yes, somebody has responded me the discrete values. Okay, in the linear regression or in the polynomial regression, under regression, how the values, see what are the target values, or the target values are continuous in nature in regression, right? Suppose you have seen some house prediction. Okay, based on the features that you have given, it may be any feature, you should predict the price of the house. Your price of the house is of continuous value, nothing but your price of the house may vary depending upon the features you have taken, right? But what is the classification means? The target values are discrete in nature. Discrete in nature means, see, your target or your attributes, see, your target might contain the values like yes or no and yes, no, or 0, 1, 2, 3. See, your target might contain the values like yes, no, or it might contain 0, 1, 2, 3, or it can also have the values like pass or fail, or it might also have some other values that it has. If you have related to the medical point of view, it will tell you that if the patient has disease or not. Okay, nothing but your target is of continuous in nature here. What do you mean by continuous? You are not having your target is of discrete here. Nothing but you are not having any continuous values. You are having some fixed values like yes or no, 0, 1, 2, 3, or pass and fail. You are having some categories in the target. Nothing but if you have the type of categorical values in the target, that data set comes under classification. Okay, let me tell you one simple example. Okay, let me tell you one simple example. If I have given you a student marks data, okay, if I have given you a student marks data, think that you have the student marks subjects. Okay, think that you are having some M1 marks, M2 subject marks, M3 subject marks, and also the physics. Okay, let think that you are having these subjects, and you are having some output column as These are the marks columns, and the output column is, let us see, if the output column, let us write some marks here: 65, 45, 75 and 34. See, I'll think that you are having some two outputs or two targets here. Okay, in one output, in one target column, you are having some 65 percentage here. Okay, in the other column you are having some information called pass. Okay, and see, if you are having some other marks, okay, let us think you are having some 12, 13, 10, and you are having some 34 percentage here. So think that this your data set is in this way. You are having the attributes, nothing but the features or attributes or the inputs are here: M1, M2, M3 and physics. These are the subject marks. And you are having the other columns called output 1 and output 2. In the output 1, think that these two are the target columns to you. There are two target columns, and observe the difference between these two target columns. One target column has the percentage of the marks given, and one column has nothing but it is categorizing here that the student has passed in the exam or failed in the exam. As you can observe, the output 1 target or output 1 column here, the values may be continuous. See, for every person, this output may vary. See, not only for fixed persons, it will be 65%. See, for one person, it may be 65. For the other student, it may vary continuously. But here, the information which is present in the target, nothing but in the output 2 column, will be of only pass and fail, right? See, you are having only two classes here. See, two classes here, that is pass and fail. It will not vary. It will of it nothing but you are having only two discrete values called pass and fail. If you have given any other marks of a student also, your percentage might change, but the classes are pass and fail only. Nothing but it will predict, nothing but this column will have only two classes called pass or fail. It won't change. Okay, nothing but you are having only discrete values here. But when you observe the output 1 column, see, for every student, the percentage may vary. It is not fixing to only two values called pass or fail. Your percentage might vary depending upon the marks of a student. So that we can tell this output 1 column is of continuous nature by seeing the data here. And by seeing the output 2 column, we can say those are discrete values which comes under classification. And see, if you want to predict, if you are given to predict the percentage of a student, then it comes under, as these percentages may vary from student to student, we can say we can apply a regression algorithm, as our output column here is of continuous in nature, nothing but it has some continuous values. But if you have given to predict that the student has passed in the exam or failed in the exam, nothing but it is some classification here. See, it is telling that it is of pass or fail. Okay, it has some discrete values, so that if you are given to predict the student has passed or failed in the exam, then that can become under a classification data set. Okay, have you got some difference between what is classification and what is regression? Please tell me in the chat box. Please reply me in the chat box. see some simple examples. See, if in the medical analysis, okay, or in the risk assessments, what will you do? What if you have some uh, given some medical data to identify that the patient has a disease or not? That comes under classification, right? Yes, somebody is asking me, ma'am, other than 64% and 34, what it will come under? I can't get you what you have asked. See, this is only one example data I have given. See, you may be having the other percentages also here. Just I have taken some marks and given you an example. That's it. See, that is why I have told you that process of categorizing the given set of data into classes. Classes means, see, I told you your data, your target column might have yes or no. This categorizing your data, this yes or no can be called as classes. If your data has if your target column has two categories called yes or no, nothing but you can say that your target column has two classes called yes and no. And you can also say if your data is of 0, 1, 2, 3. Okay, nothing but you are having some four classes here called 0 class, 1 class, nothing but some set of data comes under 0 class, some other set of data comes under 1 class. This 0 can be referred to pass and 1 can be referred to fail, or this 0 can be referred to some average student, okay, nothing but less than 90% or greater than 90%. It may refer to any other data if it is of 0, 1, 2, 3. Okay. And in the classification, there are two types. Those are binomial classification and multi-class classification. What do you mean by binomial? I think you know what is the general meaning of binomial. What is meant by binomial here? See, actually by means if you have any two variables or if you are having any two, you can say that it is binomial. Okay. When the binomial classification means, see, if your target column has only two classes. Two classes means, see, if your target think that your target column has yes or no. That means you are having only two classes. If your target column has only two classes, then it comes under binomial classification. What is multi-class? If your target column has more than two classes like 0, 1, 2, 3, okay. If you may have any other classifications here. Okay. See here, if you are having 0, 1, 2, 3, or you are having some different flowers names or different fruit names, you can say that it is of multi-class classification. And here you can say it as either pass. Example I am giving here, that's it. That is about the classification in supervised learning. Okay. What is the classification? Your target column is discrete in nature. Okay. Discrete means you are having only your data is categorized into some classes, some discrete values. If it is if your data set is in that way, you can apply a classification algorithm to that. Okay. Let us see what are the algorithms present. See, you are having many algorithms in classification. So you are having some KNN algorithm, you are having the logistic, See, these are the algorithms present in your classification. And you're also having SVM. You will see all the algorithms that supports in your classification. But today we are going to learn one algorithm called KNN, and let us see by using KNN how do we classify the data here. Okay, before, see, some of the examples of classification are spam detection. See, if your mail, see, these are some examples I am giving here. Spam detection and some risk assessments. If your data set is and also we can say that medical diagnosis. These are some applications of your classification. And also we can do the image classification. Now let us start with the algorithm. The first algorithm that you are going to learn in the classification is KNN. KNN refers to K nearest neighbors. Okay, let us see how this algorithm works and how it classifies your data. And after seeing the process that it undergo, we will go with the practical way. Okay. See, think that this is your data set given. See, I have plotted my data set in this way. See, if you have plotted two features of your data set, think that it has been like this. Okay. And see here, the K refers to number of neighbors here. K refers to the number of neighbors. Let us see what are the neighbors and how do we classify this. Okay, before starting the KNN, see, if I give any fruit with comparing with which similarities, you will predict that this is an apple, this is a banana. So think that I have given you a fruit. Okay, you should name the given fruit. Okay, you should tell the name of the given fruit. By seeing the what? By seeing some features, you will tell that this is some banana, or this is some apple, or this is some mango, right? You will classify in that way. Nothing but you will compare what you have learned already. See, from the childhood onwards, if you see a red color fruit with some shape, you might predict that this is an apple, right? Nothing but you are comparing the similarities of what you have learned previously. Here also, in the KNN, if you have given any new data to, see, this is the new data set I have given, and in the supervised learning, your model will get trained with both the inputs and also the outputs. I think you are clear with the supervised learning. Okay, in the supervised learning, you are given with the inputs and also the outputs. Your model will get trained, and if I have given you any new data, it should predict me that under which classification or what is the price of the house, or you can also classify your data in supervised learning. See, I will tell you one example. You are having some think that you are having some this data called height, weight, and size. Okay. See, you are having some medium, large. You might know what is this medium, large. Okay. You are having some data set like this height, weight. Based on your height, weight, it should predict that which size of shirt or anything will suit for you. Okay. Let us see. If I have trained my model with this data, if I have given any new data, it should predict the size that suits for the person with some height or weight. Okay. This is the one data set example I am taking. See, what are the how many classes we have here from the data set you have seen here. How many classes we have in the target column? Please respond in the chat box. See, you are having some height, weight, and size. How many classes we have in the target column? And see, we can say here we have a target column called size. By seeing the data, we can tell that the target column may be size, and it has some, see, your data has classified into medium and L. See, some of you are telling that you are having 3 classes. Classes is nothing but not the columns you are having here. Please observe. Classes is nothing but into how many categories your output column has been classified here. See, your output column has the data of M and L only, right? Don't see that how many columns you have. See, columns does not refer to the classes here. Into how many categories your data has been divided, that comes under classes here. See, you are having 3 columns of data. In the 3 columns of data, by seeing, we can see the target column can be of size column, and in the size column, you can observe that your data has been classified into 2 groups called M and L. That M and L can be called as classes here. Nothing but your data is categorized into some 2 classes called medium and large here. By seeing the data set, we can observe that those are the classes. Classes is nothing but not the columns present here. Please observe. Now, can you say how many classes we have? We have some 2 classes called medium and large. Okay. If I have trained my model with this data, if I given you any data, for suppose if I given some data called 160, okay, 160 and some 58 if I have given, okay, it should predict me, the model should predict me that what size should fit for this person with the height and weight, with this height and weight. Okay, if I have given you any data. For this, what is the process that follows in KNN? Let us see. Okay. First of all, KNN tries to see, as from the general meaning, if I have given you any new data, you will compare with the other similarities. See, if I have given you some new data, what will you do? You will compare the similarities, right? See, you will compare that what you have already learned. If I have given you an apple, think that you don't know that it is an apple, but by seeing the color and the shape, you have already learned that which is of some heart shape and red in color, you might predict that as apple, right? Nothing but it k nearest neighbors follows the similarity. Nothing but it find out the similarities and predicts the outputs. Okay, let us see how it find out the similarities. It find out the similarities by comparing the distances. Okay, nothing but it calculates some distances. See, if I have given a new data set here, think that this is the new data point. New data point means see, you have trained your model with this data and I am giving some new data which is not present here. It should predict me the output. Okay. Think that this red color point is a new data here. Okay. How KNN will classify this data and predict you as L or M? Let us see. See here, it will find out the distance. It will find out the distance from this point to the every point in your data set. Okay. This is, red color point is a new data point and blue color points are the data points that you have already trained with your model. Okay, if you have given any new point, it tries to find out the distance from that point to all the other data points given in the data set. Okay, it tries to find out the distances from the new data point to all the other data sets that you have trained with the model. Nothing but it tries to find out the distance between 2 points. What is the general formula that will you use to find out the distance between 2 points? I think we all know the general maths, right? Tell me if you remember the distance between 2 points. What is the formula? Yes, somebody has responded me that D2 minus D1. Okay. Is there anybody who knows the distance between 2 points? Okay, generally to find out the distance between the 2 points, we use the formula called Euclidean distance, which is some square root of x2 minus x1 square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is a general formula it follows. In KNN also, it tries to calculate the distance between all the points, okay, from this new data set. And now after finding out the distance, okay, let us see, after finding out the distance, what will it do? Now it should compare the output columns. Okay, see, think that it has calculated all the distances. Okay, and see, with think that it has calculated the distance, and let us see, it has some distances of 10, 2, 5, 6, 9, 15. Okay, think that for you are having some data sets in this way, it has calculated the distances. Okay, what are the minimum, what are the similar, nothing but what are the points that are very close to this new data set? Can you say, think that this is 1. Okay, tell me which distances are very close from this data point, which points are very close from this data set. See, this 2 is very close, this 5 is very close. Think that this is 2 is the first that is very close to the new given data point, and next 5 is very close to the new data point, and then 6 and then 9, right? Okay, nothing but it compares the data which is very close to this. Okay, it may compare. See, it may have something that it is having some 2, 5, 6, 9 after 10. It is having some closest distances, that closest data points around this. But it, see, we can compare with only one data point that is very close to this. We can also compare two data points that is very close to that new data point. That means two data points. And we can also compare the three data points which are very close to the new data point. We can compare n data points which are very close to the data point, right? Yes or no? See, think that this red data is very close to these two data points. Yes, we can compare these two data points also. And this new data is nearer to these two data points also. Yes or no? But what is the minimum value, the minimum data points we should consider to compare the values? See, it can compare with either two values. It can compare either with, see, it can compare with two values, and it can also compare with three values, nothing but the three other new data points. It can also compare with the other data points. See, think that here it is comparing with 2, it is comparing with 3, and it is comparing with some 5 here. Nothing but we should choose this nearest neighbors. See, nothing but we are trying to compare with two nearest neighbors here. We are trying to compare with three nearest neighbors here. That nearest neighbors represents the k parameter here. Okay, that nearest neighbors can be called as k here. Okay, in KNN you have seen k nearest neighbors. K refers to the number of nearest neighbors. Okay, and we should choose the value of k here. It is our duty to choose how many nearest neighbors we should compare with for the new data to be classified. Okay, are you following with me? Please respond me in the chat box once. What I am trying to say, are you following or not? Okay. See here, the k refers to the number of nearest neighbors, and it's our duty to choose the value of k, to choose the number of values to be compared with our new data set to predict our value. Okay. How do we choose the value of k? See, we can choose that we should only compare with 2, we should only compare with 3 nearest neighbors. Okay, we should choose some optimal value of k. To choose that optimal value of k, the math behind it is we can find out the square root of n here. Okay, we should find out the square root of n to find out, see, to choose the value of k, you should find out the square root of n. What is n refers to? N is the number of samples or the number of inputs. What are inputs? I think you know that terminology called inputs, attributes, features. What are the inputs here? Tell me, what are the inputs in this data? What are the inputs in this data set? Yes, height and weight are the inputs of the data, or you can also call it as attributes, or also you can call it as features. Okay, these are the inputs here. Okay, to choose the optimal value of k, we should find out the square root of n. Okay, think that you are having some 10 values here or 9 values here. Okay, think that you are having some 9 values. If you have some 9 values, if you have find out the square root, what is a k value? Think that you are having some, you got k equal to 3. Nothing but it tries to find out. Now let me tell you. Now you got, see, you got the for one data point, you got the distance as 2, 10, 2, 3, 5, and you got some distance 0, and you also got some distance 50. Think that for the data points you have, for the height and weight you have, you got the distance of 10, 2, 3, some 5, 0, 15. Okay, assume. Here we have chosen the value of k equal to 3, right? Now we have to compare with only the 3 nearest neighbors from the new data set. What are the 3 nearest neighbors? By seeing the distance values, we can say that the 3 nearest neighbors are, see, by seeing the distance here, we can say the first three nearest neighbors are, this is the first nearest neighbor. Okay, this is the second nearest neighbor. Yes, 0, 2, 3 are the first 3 nearest neighbors, right? Okay, think that it is having some 160, okay, 58 or 59. Think that this person with this distance have the data of 160 comma 59. Okay, this distance having some 161 comma 60. Okay, let us think that it is having some 165 comma 63. Okay, for these data points, our new data set to be predicted, think that it has been 160 comma 58. Okay, this is the new data point to be predicted. Okay, it find out the distances from these two data points, from this new data point to all the data points in your data set, and it has find out the distance, and we have chosen the value of k as 3 by calculating the square root of your samples. Okay, nothing but if you are having some 10 samples means nothing but the number of rows you have. Okay, that you will find out the square. If you have some 20 rows of data in your data set, that comes under samples, okay, or inputs. You have calculated the distance. See, by comparing with the 3 nearest neighbors, and these are the 3 nearest neighbors, and you have already trained your data. For this data set, it is of large. Okay, think that it is of medium, the output data. For this data set, it is having some large. Okay, it is have medium. Can you say it will compare with these 3 data points only, and for these 3 data points the output is medium, large and medium. Can you say that for this value 160 comma 58, which value will it predict, either medium or large? Please tell me. Yes, it absolutely predicts your data as medium only. See, this, as this data is very nearer to this data set and this data set, as we are comparing with 3 data sets, it will compare with the 3 nearest neighbors, and for the 3 nearest neighbors, the new data point we have given has more similarities with some this medium shut size. Okay, so it directly predicts this new data point as medium. Nothing but it classifies your data under the class called medium. This is the procedure that undergoes in KNN. Have you understood this? Please tell me. This is the process that undergoes in k nearest neighbors. It tries to find out the distance of every point in your data set, and it chooses the value of k. By choosing the similarities, it will classify your data. If you have any doubts in this, you can ask now. What is the procedure that has been undergoing behind the KNN? See, you need not do all these mathematical calculations. See, directly we are importing the data set, right? Nothing but we are using the sklearn library. Your sklearn will do all these calculations. You are not supposed to choose the value of k. You are not supposed to do any calculations here. That all calculations will be done by sklearn module. Just we have to import the sklearn and apply the algorithm. That's it. Okay. Shall we continue with the practical way using sklearn? Please respond. Shall we continue? Yes, thank you. I think you know what are the steps that you are doing with the algorithm. First, we should apply nothing but you should read the data. Nothing but you should read the data set, right? What that is the first step. Yes, get the data. To get the data, you need some data set here. See, I will give you, let us apply this small data set and after that we will apply one default data set that is present in our sklearn. First, let us apply this data set. Okay, this is one small data set we have. Let us apply this one. First, I will post it in the chat box. Please copy this data set and I will tell you how to create an CSV file. See, I have posted some data in the chat box. Please try to copy that one and see this is in which folder you are doing. The folder that you are doing, please open that folder, that path and take new text file. See, copy the data which I have posted in the chat box and come to the part that you are doing now and click on new text file, and if you click on the text file, a new text file will be opened. Try to paste your data there. Try to rename your text file here. I am renaming it as shirt.csv. Shirt.csv. Okay, again I am repeating here. Try to copy the data which I have posted in the chat box and open the folder that you are doing. Click on new, click on text file. If you have clicked on text file, a new text file will be opened. Try to paste your data in the text file that you have opened now and try to rename it as shut.csv. And don't forget to save. If you have completed this process, please respond me in the chat box. I will continue. If you want me to repeat the process that I have done here, you can ask if you have doubt. I will tell you. Yes, some 5 to 6 members have responded. What about the others? Yes. See, and we have created our own data set here. Nothing but we have created a CSV file, and let us see how to read the data, how to get the data here. See, in order to read your data, you should use the library called pandas, right? Import, try to import the pandas library here. Import pandas as PD. Now, to read your CSV file, you should use the method called read underscore CSV, and you should give the path of your file here. Since my folder, nothing but the notebook that I am currently doing and the CSV file are present in the same folder, I am not giving the whole path since they are present in the same folder. Just I am giving as shirt.csv. If your file is present in the other path, now is my screen visible? Yes, thank you. See, this is how you import the data, and let us store that in a data frame df. See, as our file shirt.csv and the Python notebook is present in the same folder, we can right away give it as shirt.csv here. Actually, we should give the path. Okay, I'm not giving the whole path here, simply giving the file name only. Why? Since my file and the notebook are present in the same folder. If your CSV file is present in the other path called documents or your favorites, okay, you should give the whole path here. Please remember that. And this is how you load your data here. And if you give some head method here, it will display the first 5 elements only, the first 5 rows of your data. I think you know what is head and tail. Head gives the first 5 rows of your data set, tail gives the last 5 rows of your data set. And if you want only the particular rows of data, you can give df.head of 3 or 5 or 10. You can give it like that. Okay, if you want some particular number of rows only. This is how we load our data. Now, what is the next step? What is the next step in our data? Nothing but in our process of applying the algorithm. Pre-processing. Okay, pre-processing means nothing but, see, our data is fine. You can see there is no need of pre-processing here. It is in the correct way only. And let us see, you are having some you can see if your data has some null values or not. How do we see if our data has null values or is missing information? Okay, as we have taken a very small data set which we don't have any missing values, and also we are not having, we need not process data. And let us see, S is NA is a method. DF is our data frame. We are checking, is there any null values? Okay, is there any null values is NA, and we are trying to do the sum. See if we are getting as 0, nothing but we are not having any null values here. What is the next step? We have done with the processing. We need not do any processing here. As we don't have any missing values, or we are having some correct sort of data here. And next, let us, before training the model, we should select the inputs and outputs here, right? It is our choice to select the dependent and independent variables. Okay, what are the dependent variables here? What are the dependent attributes here? See, height and weight are the independent variables. Size is a dependent variable. Yes, by depending upon the height and weight only, the size is getting predicted, right? So that size comes under dependent, height and weight comes under independent. To train our model, we should now select our features. Okay, before selecting the features, see here our data is in some string values. See, your M and L comes under the string data type, right? If you apply the string data type to your model, it won't accept. It will raise an error. It can't understand this data called string data. Okay, we need to convert into integer data. See, your target label is size, and in the target label you are having some classes called M and L, which is of string data. If you are trying to train your model with the string data, it won't accept the string data. Now it's our duty to convert this string data into, yes, into zeros or ones or into some integers. Okay, let us convert our data now. We are having some pre-processing libraries to convert our data. See, you may convert your data string data into integers data using some methods called label encoder, one hot encoding, and you can also use some dummies method in pandas. Okay, today I am going to tell you the label encoder, which converts your string data into some categorical values. Okay, and you will be knowing that on one hot encoding and also dummies method in the further classes. And let us to convert the string data of the target column, we use label encoder. See, this is one pre-processing. Okay, we have find out whether there are any null values, and but this is also one pre-processing here. Nothing but we are pre-processing our data, converting our data here. Okay, to pre-process that, we should import from sklearn dot pre-processing, from sklearn dot pre-processing import label encoder. See, label encoder tries to convert your string data into the categorical data. Okay, categorical data means nothing but your 0, 1 or anything. Okay, and next try to apply See, I am creating an object for the label encoder. Okay. I am taking the variable name as label encoder only, and it's your choice to take any variable here. Try to create an object. And now what is the column that you want to encode here? You should apply to the label encoder and you should transform it. Okay, I want to convert this column, right? To convert this column, okay, I should access that column here. How do we access a column? See, I am using some direct indexing here. df of size. See, I need to convert this column, right? So I am accessing that column. df of the name of the column is size here. I am just accessing that column. I want to encode this column, so that I am accessing this column here. df of size equal to, just call your object variable labeled encoder dot fit underscore transform of which column you need to, df of size. So you need to encode this size column in your data, right? So that I am applying that column to the label encoder, and after nothing but after getting transformed, that should be replaced with this column only, right? So that I am replacing in that column itself. Have you understood this one, this line? Now let us print our df if it has been converted or not. See, you can observe that your data has been converted into, for the m it has been converted as 1, for l it has been converted into 0. Okay, have you understood this part, this pre-processing part? Nothing but it encodes your string data into some categorical data like this. See, just we have imported the label encoder here. We try to apply the column that we want to encode here. That's it. Now our pre-processing has been completed. See, there are no missing values or none values here, and there are no string values also here. See, since we are applying, since we should give a target, nothing but we will select one target column to train our model, right? So that we are encoding the data. If a string column present in your inputs, okay, if that feature is not important to you, it is not compulsorily to nothing but if you want to skip this weight column, think that your weight column has some string data. Okay, if you want to take as a independent feature, if you want to apply this column also to your model, then you can label and nothing but encode your data. If you don't want to apply this column to your model, you can skip this column without label encoding. See, what I am trying to tell is whatever the columns that you want to apply to the model, those should be in the integer part only, nothing but integer data type only. If you want them, you can label encode. Okay, if you don't want them to apply to your model, and you need not use this label encoding. And now let us do the next part here. What is the next part? To select the independent and dependent features. See, our X has some two features. I see how do we access the data of columns height and weight. So you can use any method. Here I am using some ILOC, or you can directly access the values also. DF of height, comma, weight. Either you can use some DF of LOC, ILOC. You can use any methods if you know. See, these are the input attributes that I am taking here, and let us see if I can access them. See, X dot head of some 2. See, here I am trying to access my values, X values, and now it's our turn to also take the Y. Okay, Y is of DF of size here. Okay, you can check if your data has been accessed correctly or not. See, selecting our inputs and targets to train our model has been completed. Okay, if you have done, please respond. I will continue. Yes, now what is the next step to be done now? Please tell me. Train the model. Okay. Have you done any splitting of data in your regression? Have you done the splitting, any splitting the model or splitting the data in the regression? No. Yes, you have done. Okay. Okay, now let us split our data. Yes, to split our data, import, from sklearn dot model underscore selection import. See, as we have only small data, this splitting is not needed, but just to tell you I am doing this. Okay, from sklearn dot model underscore selection, what is the need? Okay, I will tell you what is the need to split your data. After doing this process, I will tell you. Wait. See, to split your data, I am using some train test split. So let us split our data by giving test size x train comma x test. Train underscore test underscore split. You should give some x and y values here, and you should give some test size or train size here. See, test size I am giving some 0.3 and I am giving some random state here. Okay, positional arguments. Yes, what is the mistake I have done here? I have given train test split test size as random state equal to, I have to give some value. Now let us, what is, somebody has asked me, what is the need to split the data? See, if you have given you the data set, okay, if I have given you some data set called regarding the medical analysis, okay, to find out if the patient has the heart disease or not, think that I have given you some data. Do you know the medical terms which are needed? See, you are given a heart disease data set to train your model. Okay, think that you have trained your model with the given data. To check your data, to check that your model, nothing but your machine is working properly or accurately, you need some data to test, right? How do you get that data? See, think that you are given some data related to heart disease. You have taken all the data for training your model. Okay, for training your model, you have taken all the data. Now you want to check that your machine, that your model has been working accurately or not. To check with the model that it is working accurately or correctly, you should pass some data to your model, right? How do you pass the new data to check if your model has been working accurately or not? See, you should give some new data, but you can't get the new data until you go to the hospital and take some patient's data, right? We can't get the real-time data here. Okay, to get the data, nothing but we are preserving from the given data set, we are preserving some data for testing and we are preserving some data for training. Okay, so that after training the model, we can check with the data which are preserved for testing. Have you understood who asked me this once? Yes, Rajya Lakshmi. Have you understood what is the need to split the data? Okay. See, now here we have splitted our data and I have given some test size equal to 0.3. What does it mean? Test size equal to 0.3 means nothing but I am trying to store 30% of my values in the data set for testing and other 70% of values will go for training. Okay. Have you understood this part? Why I have given test size as 0.3? See here, I am trying to split my data. Yes, I want to split my data for training and testing. Okay. To train my data, I am giving test size as 0.3. Nothing but 0.3 means refers to the testing size here, which means 30% of your values will be preserved for testing. Data set will another 70% of your data in the data preserved for training. And what is the purpose of random state? I will tell you. Wait. Now let us see what are the values that I have preserved for training. The training values which are preserved here will stored in the variable called xtrain. The values which have been preserved for testing has been stored in a variable called xtest. Okay, let me print xtrain here. See, if I give an xtrain here, and also wait, before, let me print the shape here. See how many values, how many rows of data it has been taken for test training here. It has been taken some 12 rows, and let us see what are the 12 rows here. If I give xtrain, see, these are the 12 rows it has been taken for training. See out how many rows we have. The whole data we have is some 17 rows. We have the 17 rows of data here. Okay. From the 17 rows, as we have given test size as 0.3, 70% of values will go for training. 70% means out of 17, 12 values are getting preserved for training. Okay. What are the 12 values? See, it may take some random rows of your data. See, what are the random rows it has been taken? It has been taken 13th row, 14th row, 3rd row, 15th, 17th, 11th, 12th, 16th, 17th. It has taken some random data for your training. And if I give some x test here, see x test dot shape. See, for testing, it has been preserved 6 rows. Okay. Your model will get trained data with only these 12 rows. And if you want to test that if your data has been trained correctly or not, we use these 6 rows to test our data. Okay. Since we have given some 0.3 percentage here, 0.3, it has been taken only 6 rows. Dependent on the value we have given here, it splits the rows. Okay. See, for training and testing. Have you understood up to this part? I will tell you the random state. Have you understood how your data is getting splitted here? Yes. Now what is random state here? Random state means, see, if I have taken this data, it has been taken 13 for some random rows to train, right? It has been taken some random rows. See, if I change random state as some 2 here. Now, my values for training will change. See, for one, here random state number is this number has no significance here. Don't think that if I give 23, it will take some 23 values, or don't think like that. There is no significance for this number. Just by changing a number here, you can take any number. By just changing a number here, it will shuffle your data. See, for one execution, it has been taken some these rows for training. Now I have changed one number. See, number is not the significance here. Just if you change a value here, that means it shuffles the data. Now let me see. Now let me run this again. I have run this random state by changing the random state, and now let me run xtrain here. See, now if you have taken an xtrain, the values have been changed here. Previously your values for training are different. Now your values for training has been different. Now if I change any value, see, you can give any value here. That is not a problem. You can give any value, but if you have changed any value here, it shuffles your data for training and testing. That's it. See, think that it has been taken 13, 4, 3 for one random state. If you have changed random state, it will take the other values of data for training and other values of data for testing. Okay, that is the importance of random state here. See, previously it has been taken 13, 4, 5. Now it is taking 13, 4, 3. Okay. If you change the random state, it shuffles your data for training and testing. That's it. See, now it has been taken other data, other random data from your data set for training and testing. Okay. Have you understood now what is the importance of the random state? Please respond me in the chat box. Yes, only Mastan and Rajalakshmi has responded. What about the others? If you have any doubt, you can ask me. Okay. It's nothing but we have splitted our data for training and testing. See, you can also give the train size here. You can give two attributes here. Either you can give the test size or either you can also mention the train size here. That's your choice. Okay. And this value has no significance here, but just by changing the value in the random state, your data will get shuffled for training and testing. That's it. Okay. And now let us see. Now let us apply the algorithm. From sklearn dot neighbors import k nearest neighbors. Okay, you should import this k neighbors classifier. Check the spelling of neighbors and type it correctly. And after importing the algorithm, nothing but the classifier here, just create an object KNN equal to okay. Try to fit your model here. See, to fit your model, what are the values I should pass here? Please tell me. Should I pass the training values or testing values here to train the model? Nothing but to fit. See, you should give some two variables here. Will you give the training variables or the testing variables here? You will give the training. What are the training variables? What are the training variables here? After splitting the data, we are having some training and testing variables, right? What are the training and testing variables? See, your X train and Y train are the training variables. Y X test and Y test are the testing variables. Okay. To train our model, I should give some X train comma Y train. And let me run this one. See, it has from the attributes that are present here, n underscore neighbors. How many nearest neighbors it is taking here? See, actually we can give the neighbors. How many with how many nearest neighbors if you want to compare, you should give with this attribute called n underscore neighbors. Okay. My voice is breaking. Is my voice breaking for the others also? Please respond. No. Okay, thank you. See here, you can mention the number of neighbors, nothing but you can mention the value of k with this attribute called n underscore neighbors. Okay, but if you have not mentioned, it will choose the value of k correctly using some calculations. And see here, how many with how many nearest neighbors it is comparing. It is comparing some n underscore 5 neighbors, 5 nearest neighbors you can see here. Okay, now our training the model has been completed, right? It's our turn to test the model. If it has been, say, to test the model, we have some values under in x underscore test, right? Okay, and for y underscore test, we are also having some. See, let us x underscore test dot head of 2 y underscore test. See, for this 8 11 163 and 64, these are the values we have preserved for testing. Now let us test our data. For 163 and 64, see, for 8 and row 11 columns I have been observing here. For 163 and 64, what is the value it should predict? It should predict the value as 0. Okay, let us see if it is predicting or not. Okay, KNN dot, KNN is the object variable we have been taken. KNN dot predict of, see, I am giving some 163 comma 64. If you have new data, if you have your height and width, okay, height and weight, you can give the data here and you can check which data it is predicting. Okay, see, for testing our model, I have been checking with 64 with this row of column. It should predict me as 0. Okay, let us see if it predicts as 0 or not. See, it is predicting me as 0 only. Okay, but if you have trained all your data without splitting, there are no values for you to test your model. Okay, that is why we have splitted our data to for training and testing. Okay, if you have not done this, please note it down. And if you have any doubts in this also, you can ask me now. Okay, have you completed noting it down? See, we have, my voice is breaking. Students, is my voice breaking? Please tell me. Rajalakshmi, please check your internet connection once. Yes, is my voice is breaking. Okay, wait. I will check my internet connection. Okay, now is my voice clear? Okay, see, up to now what we have done. See, we have loaded our data set, and we have done some pre-processing, and we have splitted our data, and next we have predicted our data. See, to predict all the values which are preserved for testing, what will we do? Let us see y underscore predict equal to, yes, who is that?
Ma'am,
Yes, Lakshmi, tell me.
why do we get array of 0, ma'am, when we predict that 163, 64?
See, you are trying to predict the value called one with the attributes called height and weight. It will return you in the form of array the value. See, what is the output value you should get here, either in the 0 or 1, right? It will give you in the array form.
Okay, ma'am, understand. Okay, ma'am.
I think you know the NumPy library, right? The NumPy library. It will give you in it. Your predicted values will return in the form of array. That's it. See, for 163 and 64, it is predicting the values as 0. Okay. You can give multiple values also here. You can give multiple values to predict, so that it will give you in the form of array. Since we have taken only one value, it is giving you only one value here. And let us see, to predict multiple values. Now I am giving, see, KNN dot predict of y underscore test. Sorry, x underscore test. See, here I have only predicted some one value, right? Now I am going to predict all the values which are preserved for testing. That all values are present in x underscore test variable, right? That variables I am giving. Either you can also pass in this way. All the values that you have here, you can pass in this way. 165, 62. You can pass in this way. But it is very difficult to pass all the values in this way. If you have some 90 rows, it is difficult to pass all your values in this way, right? To type all that. Okay, just we can replace that with a variable called x underscore test, as all the values for testing has preserved in this variable. Okay. See, if you can give the multiple values here. See, it will give you in the form of array. And see, I am trying to give all the values which are preserved for testing. And now y underscore predict. See, it is predicting me. It has been taken some 6 rows of data for testing, right? It is predicting that 6 values here. Okay, have you understood this? Please respond. See, if you have any new data for you, if you have any new data with height and weight, you can use that new data. Okay, you can have the height and weight of a person, but if your data set is from the other field, so say from the medical field or some business field, you might not get the data, right? Real data. So that we will preserve some values from the given data set only for testing. Verify the values means what? You're asking me to verify, or you're asking any other? Please respond once, Mastan. Okay, next let us continue. What are the metrics that you find here? See, what are the metrics we find means, what are the metrics you have find out in linear regression? Yes, predicted output values with the actual output. From sklearn dot matrix values are not changing. Why values will change? Geetika, you can unmute your mic and talk to me. Which values are not changing for you? If you have changed the random state also, your values are not changing. Yes. Wait, I will give you the presented to you. I will see your screen and clarify your doubt. Okay. After finding out the accuracy, we will do that. See, under the classification, we use a metric called accuracy score. Okay. To find out that accuracy score, you should import from matrix. You should import accuracy underscore score. Okay. How do we find out the accuracy here? See, if you have given, I will ask you one question to you. If I have given you a multiple choice exam, okay, you have attended some multiple choice exam. How do we give the marks to you? Tell me. By comparing the answers which have preserved for that questions, right? Yes or no? If I have given you any question paper to you, think that they have you have written some multiple choice questions. Okay, you are getting some marks. Okay, how do we get that marks? By comparing with the answer key, right? How do we get this accuracy score here? By comparing the answers. Okay, where are the answers here? Please tell me. Where is our question paper and where are our answers? Yes, our answers are present in our Y test. See, in the splitting of data, in the Y test, we are having the answers. And where are the predicted values? Nothing but the exam is written by the think that the exam is written by the model here. The model has predicted the values here. See, these are the answers that is given by the model. And the actual answers are present in Y test. If you compare the two values, only you will get the marks of your exam or the score of your exam, right? In the similar way, to check the accuracy score, I need to compare the Y test. Nothing but these are the actual values. Okay, these are the values predicted by the model in the Y underscore predict. I will compare those two variables here to find out the accuracy score. Print accuracy underscore score of Y underscore test comma Y underscore predict. Okay. See, Y underscore test and Y underscore predict. Let me print that. See, you are getting some accuracy called 1.0. 1.0 means 100%. And with 100% accuracy, your model got trained. Okay. Think that have you got 1 for all? Accuracy 1.0 for all? Please tell me. Or if you got some 99, 98. Have you got 1.0? 16.6. See, how do you get 16.6? Okay. Wait. See, if you want to think that I have got only some 90 here. That means your model has been with the accuracy 90 only. Okay. To improve the accuracy, you may change your values for training. See, for this set of values that has been sent to training, it has shown me, think that it has shown me some 90% only accuracy. To train your model in a better way, you should train with the different values, right? See, if the model has been trained with these values only and giving me as the accuracy as some 90, think that. Okay, but if you want to make the model to train your model well, okay, what you should do, you should train your model with some different values. Okay, I can change my training value just by changing the random state value. Okay, if I change my random state, my training values may change, right? So that it may train with some other new data and it may increase the accuracy. Okay, you can do that. This is how we calculate the accuracy score. Yes, Geetika, now try to change the random state value of your own and try to run your steps again. Check the accuracy. Yes, this is how your KNN works, and please ask me now if you have any doubts in the steps we have done. Yes, you Geetika have got the accuracy 1.0. Yes, if you change the random state, your data will get shuffled. Okay, your data, with the data you are training, accuracy may increase or decrease. That depends upon the data, with the data that your model has been trained. Okay, please keep that in mind and follow the process. Now students, you can ask me the doubts if you have in the steps that I have done now. If you have any doubt in predicting the model, or if you have any doubt in splitting the data or the variables that I have used, you can ask me now. Yes, somebody, ma'am, if you change random state 23 and run all steps, okay. See, if you have changed the random state 23, that means there the data is getting shuffled. With the data that has been shuffled, it is training with only some accuracy. Okay, you are not training your model with all the data, right? With the data, it has been trained with that much accuracy only. Okay. See, depending upon the rows of data it is been training, your accuracy differs. Okay. Yes, those training and testing, if you have not, why we are doing training and testing, I will tell you at the end of the session in the doubts from 10:30. Okay. But if you have any doubts in the procedure that I have done, you can ask me. Why we are doing training and testing, I will explain it to you at the end of the session in the doubts part. Okay. How we follow, okay, this is how we follow the steps in the classification model. Okay, wait, I will tell you why do we go for training and testing now, since nobody has asked me the other doubts. Is as random state changes, accuracy changes? Yes. If your random state change, your data will get change here, so that your accuracy will also change. Suppose మీకు ఒక సింపుల్ ఎగ్జాంపుల్ ఇస్తాను చూడండి. మీరు ఒక మ్యాథ్ ఎగ్జామ్ కి అటెండ్ అవుతున్నారు. ఓకే, మీకు ఒక 5 చాప్టర్స్ ఉన్నాయి, ఎడిషన్, సబ్ట్రాక్షన్, మల్టిప్లికేషన్, డివిజన్ చాప్టర్స్ అనుకోండి. You have learned only addition and subtraction. You did not learn multiplication and division, but you have attempted for the exam. ఓకే, మీకు ఎగ్జామ్ లో అన్ని చాప్టర్స్ నుంచి ఒక్కొక్క క్వశ్చన్ వస్తుంది. కానీ మీరు ఎన్ని ప్రిపేర్ అయ్యారు, ఎడిషన్ సబ్ట్రాక్షన్ ప్రిపేర్ అయ్యారు కాబట్టి ఆ 2 క్వశ్చన్స్ కి ఆన్సర్ చేస్తారు, మీకు ఆ మార్క్సే వస్తాయి. ఓకే, నెక్స్ట్ ఏం చేస్తారు, దాంట్లో ఫెయిల్ అయిపోయారు ఎగ్జామ్, వాట్ విల్ యూ డూ నెక్స్ట్? You will try to learn addition, subtraction along with multiplication and division, and you will attempt the exam. You will get the full marks, right? You try to answer all the questions since you have learnt all addition, subtraction, multiplication, division, and you will pass in the exam. Now you have got more knowledge than before. Yes or no? In the same way it is doing here. మీరు కొన్ని రోస్ ర్యాండమ్ డేటా తీసుకున్నప్పుడు it is taking some rows, it is having that rows having some information. Okay, with that some information it is showing that accuracy, but if you change your rows of data, it is learning more and more. If that learns more than the previous, it shows more accuracy. Have you understood now, Mahesh from Priyadarshini? Yes. And why do we take the test training and testing? Let me explain that in a simple way. Okay, if I have given you a new chocolate, ఓకే, మీ ఫ్రెండ్స్ కానీ మీ రిలేటివ్స్ లో అమెరికా నుంచి చాక్లెట్స్ తెచ్చారని ఇస్తారు. ఓకే, దట్ ఈస్ అ జనరల్ ప్రాసెస్, జనరల్ గా మనకి జరుగుతుంది అది. ఓకే, ఇప్పుడు మీరు ఒకరికి ఆ టేస్ట్ చూపిద్దాం అనుకున్నారు, అండ్ మీకు ఒక అమెరికా చాక్లెట్స్ తీసుకొచ్చారు, మీకు ఆల్రెడీ మీ దగ్గర ఓన్లీ 2 చాక్లెట్స్ ఉన్నాయి, 3 ఉన్నాయి అనుకోండి. 2 చాక్లెట్స్ ఇచ్చేసి మీరు ఏం చేశారంటే టేస్ట్ చూపించేశారు. ఓకే, ఇప్పుడు మిక్స్ ఆఫ్ చాక్లెట్స్ ఉన్నాయి, అంటే అమెరికా చాక్లెట్ తో పాటు మన ఇండియన్ చాక్లెట్స్ కూడా ఉన్నాయి. తను టేస్ట్ చేసి, అంటే ఆల్రెడీ 2 చాక్లెట్స్ తో టేస్ట్ చేసేసింది తను, మీ ఫ్రెండ్. మీరు ఇప్పుడు ఏమి ఇచ్చారు, ఒక బౌల్లో ఇండియన్ చాక్లెట్స్, అమెరికన్ చాక్లెట్స్ కలిపి ఇచ్చేసారు. ఆ టేస్ట్ చూసి తను చెప్పాలి ఇది అమెరికన్ చాక్లెటా, ఇండియన్ చాక్లెటా అని. మీ దగ్గర ఉన్న 3లో 3 తనకి టేస్ట్ చూపించేస్తే ఇంకో చాక్లెట్ ఇవ్వడానికి ఉంటుందా, మీరు టెస్ట్ చేయడానికి? ఉండదు. మీరు ఏం చేస్తారు, టెస్ట్ చేయడానికి ఒక చాక్లెట్ ఉంచి 2 చాక్లెట్స్ మాత్రమే ఇస్తారు. ఓకే, అప్పుడు మన టెస్ట్ చేయడానికి, అంటే మీరు టేస్ట్ చూపించడానికి 2 చాక్లెట్స్ ఉంచుకుంటారు, మళ్ళీ మీరు దాంతో గేమ్ ఆడడానికి, టెస్టింగ్ గేమ్ ఆడడానికి ఒక చాక్లెట్ పక్కన ఉంచుకుంటారు. అవునా కాదా? ఎందుకంటే మీరు మళ్ళీ వెళ్ళి అమెరికా వెళ్ళి ఆ చాక్లెట్ తేలేరు కాబట్టి ఆ 2 చాక్లెట్స్ అలా 2 చాక్లెట్స్ ఏమో టేస్ట్ చూపించడానికి ఉంచుతారు, ఒక చాక్లెట్ ఏమో టెస్ట్ చూపించడానికి, టెస్టింగ్ చేయడానికి ఉంచుకుంటారు, అలా గేమ్ ఆడుకోవడానికి ఉంచుకుంటారు. ఎస్ ఆర్ నో? అలాగే ఇక్కడ కూడా వీఆర్ ట్రయింగ్ టు see if your data is some other field which you don't know, you can't get that data. ఇప్పుడు మీరు పోలీస్ స్టేషన్ సైబర్ క్రైమ్ డేటాని యాక్సెస్ చేయాలనుకుంటున్నారు, ట్రైన్ చేయాలనుకుంటున్నారు. ఓకే, మీరు డేటా అంతా so you are doing some end to end application. You have trained your model, now your model is ready to predict your cyber crime data. మీరు ప్రిడిక్ట్ చేయాలి అంటే కొత్త డేటా ఇవ్వాలి, మీరు కరెక్ట్ గా వర్క్ అవుతుందా లేదా. మీరు వెళ్ళి సైబర్ క్రైమ్ కి వెళ్ళి మీరు డేటా ఇవ్వమనంగానే ఇవ్వరు కదా వాళ్ళు. అది ఏం చేస్తారు, ఆల్రెడీ మీ దగ్గర ఉన్న డేటాతోనే కొంత డేటా పక్కన పెట్టేసి దాన్ని ట్రైనింగ్ ఇవ్వరు, ఓన్లీ టెస్టింగ్ మాత్రమే యూజ్ చేసుకుంటారు. సో దట్ వీ కెన్ use that values for testing. You can't get the data directly if you go to the police and if you ask the data regarding your cyber crime, you can't get all the data. Okay, with the data you have already there with you, you should do training and testing with that data only. You should test your model with that data, you have to train your model with that data. Okay, టు ప్రిజర్వ్ సమ్ డేటా, మీరు టెస్ట్ చేయడానికి కొంత డేటా ఉంచుకోవడానికి మీరు డేటాని ఇక్కడ స్ప్లిట్ చేస్తున్నారు అంతే. ఇఫ్ యూ హ్యావ్ ట్రైన్డ్ ఆల్ యువర్ డేటా విచ్ యూ హ్యావ్ గివెన్ టు యూ, దెర్ ఈస్ నో వాల్యూ, దెర్ ఈస్ నో డేటా టు యూ టు టెస్ట్. You should get the data, new data from the other source. Okay, you might not get the data from the other source. Okay, that is why we do training and testing. Have you understood, or shall I tell you in the other way, with the other example? Rajya Lakshmi. Okay, if you have not understood yet, you can ask me again. Okay, still if you have any doubts in this, you can ask me why do we use the random state. Okay, if you have no doubts, we will do one other data set here now to make you understand in a better way. Yes. Okay, let us now do with the other data set. The same KNN let us apply to the other data set. See, we have applied some to the data set called shirt.csv. Now let us apply the data set. See, apply KNN to the iris data set. Okay. See, this iris data set is present in your sklearn. How to load the data which is already present in our sklearn? Okay. Let us do that first. From sklearn dot datasets import load underscore iris. See, your sklearn has some inbuilt data sets. Okay, from that I am using some iris data set which is present. See, to let us create a data frame iris underscore df equal to, just I am creating an object for this object variable or reference variable. Iris. Okay, this is the reference variable I am going to use for this iris. Okay, iris underscore df dot keys. If I give keys here, see, it will give me what are all the keys present for this data set. Okay, for this iris data. If I want to know the description of this data set, what should we do? Iris underscore df is my reference variable I should use for the data set. Iris underscore df dot descr is my key here. See, descr is for description. Let us see the description here. Let's try to print so that you will get in new lines. See, if you can see the description here, how many instances you are having here? Nothing but instances means number of rows of data here. Okay, see, you are having some 150 rows of data. 50 in each of 3 classes means, what do you mean by this? You are having some 3 classes. Classes means into how many categories your data has been divided. Okay, those are the classes here. Out of 150, okay, you are having 3 classes, right? For each class you are having some 50 rows of data. What are the 3 classes? See, in the class you have some iris. Iris is the flower. Okay, if you see the iris flower here, wait, I will see. If you see the iris flower, in this flower only there are 3 types of species in the 3 types. Okay, in this flower there are 3 types. Okay, what are the 3 types in this flower? Or in the iris you will be having 3 species called setosa, versicolor and virginica. These are the 3 classes that are present in your output column. See, for setosa species, you are having 50 rows of information. For versicolor, you are having 50 rows of information. For virginica, you are having some 50 rows of information. Okay. Yes, I will show the code. Wait. And next, what is the information you have? That 150 rows of data, what is the information you have means these are the attributes information. What are the attributes? You are having some sepal. I think you know what is petal and sepal for a flower. Okay. You are having some sepal length, sepal width, petal length, and petal width. Okay. Based on these features or attributes, you are having that this based on the sepal length, sepal width, petal length, and petal width. Your iris flower is been categorized into some 3 classes called setosa, versicolor, and virginica. Okay, this is the information that you will be having in your data set. And see, you can you are having some minimum value or maximum value of your data set. Okay, and you can also read this description if you want. And see, somebody asked me to display the code. Yes, this is the code that I have used here. Now let us create a data frame from this data set. Okay, from this information, let us create a data frame. What are the target names? What are the feature names are present in this keys? Feature underscore names and target underscore names. The data, nothing but the sepal length data, petal width data, all the data is present in this variable called data. Okay. And if you see the file, as I have said, this is the inbuilt data set from the sklearn. In your system, it will be present in some path, right? If you want to know that path, you can use the file name here. Okay. Have you understood this part? How to load a data set which is already present? Nothing but which is already present in your sklearn. Please respond in the chat box. Students, have you understood this part? How to load your data set which is already present in sklearn? Please respond. Only Mahalakshmi has responded. What about the others? See, as this is online class, with your response only we can continue. Otherwise, we will be not knowing that you have understood or not. Your response is most important here. Okay, thank you. See, to see the file path here, iris underscore df dot file name. See, whatever the name present here, you should use that only. You can't change that. Okay, you should not change the key. Yeah, iris underscore df, right? My variable is iris underscore df. See, this is the path where your data is present in your system. Okay. Now let us create a data. See, we are having more and more information here. Now, whatever the data we want, we will use the data and we will frame our data frame. Okay. See, to frame our data frame, you should import pandas. We have done already. Okay. Now, to create a data frame, we should use a method called, in the pandas, we should use a method called data frame. PD dot data frame of, what are the attributes we should give in this data frame? The data which we want to get. Okay, iris underscore df Okay, in this iris underscore df, nothing but the values of your sepal length, sepal width, all the values are present in this variable called data. Okay, so that I am giving that data here, iris underscore df dot data. If you give some simply like this, see I am giving it as df. Now df dot head. If I give simply like this, see your data frame would be in this way. You are getting some values like 5.1, 3.5, 1.4, and your by default your columns are 0, 1, 2, 3. But we have some names for it, right? We have some sepal length, sepal width, petal length, and petal width for that. To name that values, we can give the columns attribute here. Columns equal to the column names are present in this key called feature underscore names. Okay, your column names or attributes are present in this key called feature underscore names. So that I am giving that key here. That key is present in iris underscore df dot feature underscore names. Okay, with this nothing but I am giving the column names here. Where are the column names present? In the key called feature underscore names. This feature underscore names is present underscore in this data frame, nothing but in this iris data set. See, now we got the names of our columns. The sepal length, sepal width, petal length, and petal width. See, we have taken only the attributes here, but we don't have any target column, right? In supervised learning, we should train our data with the target and with the inputs. But we have not taken the target. Let us take the target also. To take the target, I am giving the name as target only. My output column, I am naming it as target. Okay. In the output column, see, where is your target information present? Your target information is present in, see here, in the variable called target only. I am using that variable here. Iris underscore df dot target. See, in this the information is present, but the column name will not be present. Okay, so that I am giving a new column name called target. It's our choice to give any name. Now, see here our target is added here 0, 1 and so on. Okay, see here 0 represents, see you are having 3 classes, right? Setosa, versicolor and virginica. But your targets are here 0, 1, 2. Okay, if you see here, see if you see iris underscore df dot target underscore names. If you see target underscore names, see actually your names are Setosa, versicolor and virginica. But here they are classified into 0, 1, 2. That means 0 refers to Setosa, 1 refers to versicolor, 2 refers to virginica. Okay. We can't place this Setosa, versicolor, virginica here. Why? If you have placed this also here, you need to again pre-process that one using some label encoding. But here we have in the form of integers only, in the form of 0, 1, 2. 0 refers to Setosa, 1 refers to versicolor and 2 represents virginica. Have you understood this part? Please respond, and if you have any doubt in this also, you can ask me now. Yes, loading our data frame has been completed successfully. Now our current data, nothing but actual data, is present in DF. Now you try to apply the KNN to you and tell me the accuracy score. See, framing the data has been completed, nothing but getting the data has been completed. Now it's your turn to process your data, split your data, apply the algorithm. Okay. Please try to apply the steps that you have done previously with the shared data set and tell me the accuracy for me. Will you try that? Will you do that? Please tell me. Now you will be able to understand the steps that you have done. Okay. Think and do and tell me the accuracy. Students, are you able to apply the steps? Okay. If you have done, you can tell me, you can post the accuracy that you have got. Yes, Mastan has got 95. See, your accuracy may differ from one person to the other. Okay, that is why I am asking your accuracy. Mastan has got 95. The other can get the other percentage of accuracy. Okay, if you have completed, please post the accuracy. Okay, let me also do and check the accuracy here. See, to access nothing but the features I am going to take for training, or I am taking all the features. df dot ILOC. I am using ILOC here. Okay, I want all the rows of data and I want the columns from 0 to 4. If you can check here, x dot head of 2. So I am accessing only the 4 columns here in x, and y is a target variable. The target variable is present in some with the name called target only. Y dot head of 2. After selecting the dependent and independent variables here, we should split our data and apply the algorithm. To split the data, you need to import train test split, right? So just I am copying the lines that. See, I have chosen to select x and y here. What are the dependent and independent variables I have chosen? I have used some ILOC here. You can use any method to access your data. That's our wish. Okay. See, previously I have directly given the column names that I want to access. Here I have used now the ILOC. You may use any method. And the target column is I have taken in the variable called y, and I am doing some training here. Nothing but split. I have splitted my data, and now it's my turn to apply the algorithm. To apply the algorithm, we should import neighbors from sklearn. And next, it is To predict the values, what should we do here? Y dot predict equal to KNN dot predict of x underscore test. If you can print y underscore predict, see, it is predicting you in this way. Now let us find out the matrix, find out the accuracy here. To find out the accuracy, we should import a metric from sklearn called accuracy underscore score. Okay, let us print that one here. See, I got some 95% accuracy. See, if you want to shuffle your data and again train your data, what will you do? If you want to shuffle your data, see, you may shuffle your data by changing a random state here. Nothing but changing a number means nothing but you are shuffling your data, and again I am training with the shuffled data. And I am trying to again. See, even though I shuffle my data, I got 95% again. Okay, let me again shuffle my data so that your accuracy may decrease or increase. Say I am giving some 2. See, I got some accuracy called 1.0 now. Why? See, with this data that has been shuffled, it is giving me 1.0. Okay, but that's not okay. Your accuracy may change from the data to data. Okay, the data which you have been taken. See, now again I have shuffled my data. It has been giving me some 91%. Okay. See, depends upon your data, it is giving you the accuracy score. That's it. See, most of you have got 95% of accuracy for this iris dataset when you apply a KNN algorithm. Most of you have got some 95%. Okay. And this is one of the algorithm in your classification. That's it for today. And if you have any doubts regarding the concept that we have teach today, you can ask me now. From 10:30 to 11 it's doubts clarification session, right? If you have any doubts now, you can ask me. Thank you one and all.